Hey, Kayan, let's see how this goes. It might be a little clunky because I'm using a new computer. I'm not used to it. All right. See if I can move the screen. I just wanted to check on this page number. All right, page 9. Right, I numbered your packet. So I didn't number the back sides, just the front sides. But you can see these things are numbered 9, 10. So you could fast forward through this video. You could fast forward through this video and get to the page you want to get to by looking at those page numbers, I guess. Hopefully that helps. You see those things? 17 is that one right there. Oh, my cursor doesn't show up. 17, bottom right corner. And I'm starting on page 9. The first few pages I didn't take a picture of because we finished, I guess, most of those. All right. These shouldn't be too hard. You've seen this stuff before, I think, but it has been all summer long. So here I'm starting with this problem, and I'm trying to get W by itself, which means that -4's got to go. And how do I get rid of a -4? In other words, a subtract 4. I add 4 to both sides. Got to do it to both sides to balance it out. So -4 plus 4 just goes away. Boom. And then I got to take care of the right side. 5 plus 4 is 9. And we're all set. W's by itself. W is greater than or equal to 9. Let's see, did I graph it? So to graph it, you can put the 9 anywhere you want. That's our limit. Yeah, I could have put it on any tick mark. I just randomly choose this one. And I have to put a dot. So it's either closed or open. Because it's greater than or equal to, it includes 9. Therefore, it's a closed dot, which means it includes 9. Greater than or equal to is closed dot. And this says W is bigger than 9, greater than 9. This one's bigger, this one's smaller. So if I want to indicate everything that's bigger than 9, I have to shade to the right side. These are all the numbers that are bigger than 9. So all of these numbers are potential W's. They're all bigger than 9. All right, let's try another one. All right, in this one, we're trying to get the variable alone. In this case, our variable is C. And it's accompanied currently by a multiply by 7. So how do we get rid of 7 times or multiply by 7? We do the opposite of multiplication, division. So we divide both sides by 7. Doing that cancels out the multiply by 7, leaving us with C by itself. And on the right side, -28 divided by 7, -4. So C, our variable, is some number that is bigger than -4. So it could be -3, it could be 1,000, it could be 0. All those numbers are greater than -4. Can't be -5 though, and it can't be -4.1. Those numbers are smaller than -4. All right, let's make that graph. I need to put some kind of dot on -4. Should it be open or closed dot? Since it has to be greater than 4, it can't be equal to -4. So it excludes -4. I need an open dot. Greater than is open dot. C is bigger than -4, so I need to shade to the right. These are all the numbers that C could possibly be. It could be -3, it could be -2, it could be 0, it could be 1, or it could even be 1,000. All right. I'm going to try and go through these quicker. Here I'm multiplying both sides by -3, which cancels out divide by -3, leaving me with just the A. And then to graph it, it's a closed dot at 15, and it's greater than, so I graph to the right. Jump ahead a little bit. No big deal. Let's skip about this one. Got some weird fractions in this one. All right. So it's subtract by 1 2/3. I need z by itself. So I need to add 1 2/3 to both sides. That's all fine, but oh, now I got to deal with these rotten fractions. So you're probably hopefully just like reaching for your calculator right now. But eventually you probably should review this. We did a little bit last time we met. How to convert, without a calculator, how to convert a mixed fraction into an improper fraction. And you said it last time. You do 1 times 3, and then add it to the numerator. 1 times 3 is 3. 3 plus 2 is 5. So we've switched to a mixed fraction. And we're not done yet because now we need a common denominator, which you're also really good at. So I'm sure in your head you're already saying 6. 6. Say 6, Eric. Yep, you're right. 6. And then I'll just skip ahead to the answer, 5/2. And of course, if you didn't want to do all that, you could grab your calculator. I forget where the buttons are, but there's a button where you can enter a mixed fraction and a regular fraction and add them together. And then the calculator will spit out an improper fraction. All right. So as far as graphing, we've got z is greater than, so open dot at 5/2. We could just put anywhere. There's nothing special about this particular tick mark. You can choose any of them randomly. All right. I suppose, now I'm thinking about it, I bet your teacher's gonna, Yeah, you can put that tick mark anywhere you want, but I wonder if your teacher's gonna have like a different opinion on that. Especially since this is 5/2. She might say, no, since it's a fraction, it has to be between integer values. Maybe she would want something like this. Before I mark it, do you know where 5/2 is? Now that I've assigned a scale. Let's count it out. 0 and then 1/2. 2/2, 3/2, 4/2, 5/2. I'll put an open circle there and then shade to the right. I'm pausing, kind of just thinking about what your teacher would want. She'd probably prefer this, but this would be another option. Yeah, sorry, I can't give you a definite answer on which one of these she would accept, or he would accept, I don't know. But definitely they would accept this one if you want to put in the extra effort. Oops. Determine whether the given value is a solution to the inequality. Let's check that out. What are they even talking about? Determine, figure out, find out, decide whether it's true or false. The given value, and that's this guy. They're giving us a value for x. Determine whether this value is a solution to this inequality. So if we're going to see if this value works in the inequality, we plug it in. And plug it in means we replace this variable with this value, this number. So here I go. I'm going to replace that x with the number they told me to replace it with, negative 13. Then I'll write the rest of the inequality the way it was. And then I'll look at it and I'll decide if that's a true or a false statement. It's not that obvious because it's negative numbers. At first glance, it seems like 13's got to be bigger than 9. But since it's a bigger negative number, it's actually the opposite direction, and negative 13 is in fact smaller than negative 9. So yes. This last one, when you plug in the number, you're going to get a fraction equals a fraction. You might have to think about that one. You could pause here and think about it. Is 17 over 20, is it bigger than 3/4? Hard to say. So pause it and think about it for a second. Okay, here we go. So if you want to compare them, you would need a common something. So see if you can work that out, okay? A common something. All right, here we've got some busy work. I think you definitely want to focus on your fractions and decimals. This one's not super important. So maybe you just copy all these answers. You could do a couple of them, but don't spend your brain energy on this particular page. Just write down the points. Yeah, and they're talking about ratios and proportions. I'll go over a couple, but don't put too much energy into this one. A's to B's. So they're saying count up all the A's, and let's see, that's 5, 10, 12 A's, and there's 5 plus 3 is 8 B's. So A to B is 12 to 8, and then reduce that fraction or that ratio. Express it like that. And then there's two other ways to express a ratio. 3/2 or 3 to 2, or verbally saying it 3 to 2. All right. And let's see, anything else interesting on here? And maybe these word problems would be all right to go over. But they're not that easy. I don't know. I don't remember if you're good at these ones. I know you're really getting good at your fractions. Let's see. All right. To create a certain color, Marie mixes 3 drops of blue for every 5 drops of red. So I'm going to write that like this. 3 blue to 5 red. Right over here to remind myself. If she uses 18 drops of blue, it's got to go in the top because I've got blues in the top. Blue to red. I want blue to red. And I'll put an X there for the red drops. So how to solve that? Eek. It's complicated. We've got fractions and a variable and an equation. So you can pause and think about it. The technique we usually use is cross multiply or butterfly method. The bottom numbers go up on the opposite side. So this will be 3x on the left side, and on the right side we'll get, let's see, 50 plus 40, 90. And then divide by 3. X equals 30. All right, try to do this one on your own also. I remember the tests where you had these. So yeah, you definitely had these before. Oh, there goes my Alexa. So there's not one method to these. There's different techniques depending on what you have and what you want. All right, so for this one, the 10 wasn't there before. So I can either divide 8 by some number, figure out what 8 is divided by to get 5, and then use that number to divide 16. But I can see that's not a nice integer number. So I'll look in this direction. 8 times 2 is 16. Therefore, if I multiply this number by 2, I can get 10. All right, so this was not there before. So now I look at these ones and I say, okay, should I multiply 10 by something to get 16? But I see that's not a nice integer number. And so then maybe I look at 10 and 25. 10 times what is 25? That's also not very convenient. So I'm going to get tricky with it, and I'm going to go up here to this 5. 5 times what is 25? Okay, there's a nice integer number, so I can use that over here, times 5. So, I don't know, maybe these are kind of fun. Maybe it's kind of like a game, seeing which direction you can copy. Let's see. This one will work multiple ways. If I divide 5 by 5, I get 1, so I can divide by 5. Looks like I wrote the wrong answer, dang it. Let me try it the other way. 5 times what is 80? And you might need your calculator for that, but I think it's 16. So, whoops, I should have multiplied 1 by 16 to get 20. All right, so 5 times 16 is 80. So therefore 12 times 16 will give me the correct number. Let's see. Is that even right? Alexa, what's 12 times 16?
192.
Okay, so that one's okay. All right, you can try that one on your own. Jeremy's car salesman last year, 2 trucks for every 3 cars he sold. I messed this one up too. Dang it. I think I was in too much of a hurry. All right, I got to blank all these out. Let's see, how could I do that? It should have been 3 cars. So for every 2 trucks he sells, there's 3 cars he sells. So then I'm going to add another 2 cars, another 2 trucks, which means I'm going to have to add 6 cars. And if he sells even another 2 trucks, then he's going to sell another 3 cars. If he sells another 2 trucks, another 3 cars. All right. So this didn't have labels. Actually, I wonder if truck should be down here. It's not set in stone. You could go either way. So I'm just going to leave cars down there. All right, so 3 cars and 2 trucks. So this point tells us if we have 3 cars, that point corresponds to 2 trucks. Four cars, 6 trucks. Wait, no. 6 cars, 4 trucks. 9 cars, 6 trucks. 1, 2, 3, 4, 5, 6. 12 cars, 8 trucks. I guess we didn't use the point 0, 0. I mean, it's on our graph, but we could have put that in our table also. The rest of these, you should probably just copy these down and not read it too much. I just don't think this is one of the more important topics for you to study next year, or to study this summer to prepare for next year. It's my dog barking at a squirrel. I don't know if you can hear that. All right. Determine whether equality shown in table represent proportional relationship. Proportionality. Yeah, you definitely had these last year also. So you might remember let's see, you see what is added here and see what's added here. And then you do it again and again. 32 and 16. Yeah, my math's not that good today. All right, 16. So they're all the same. So that doesn't necessarily mean it's proportional. It also has to go through 0, 0. Now that I'm thinking about it, we used a different method to determine proportionality. I think. Actually, I don't remember the way you guys did it. So I'll give you a couple methods and then you decide. We might have also done 16 divided by 5 and 32 divided by 10. And if all these come out to be the same, yeah, this is probably the safer method. Alexa, what's 16 divided by 5?
16 divided by 5.
I don't even need to do that. She said 3.2. So I could test that for all of these 3.2, but I can also see that these all reduce to the same fraction. So this one is proportional, yes. I'll use that same method here. 28 divided by 2 is 14. 42 divided by 3. I guess you could reach for your calculator for that one. Alexa, what's 42 divided by 3?
42 divided by 3 is 14.
It looks like I'll get the same answer for all these. So therefore that one is also proportional. So let's see what happens. How do we know this one's a no? 8 over 2, 4. 20 over 5 looks good so far. 4. 42 over 12. That's a maybe. Alexa, what's 42 divided by 12?
42 divided by 12.
Oops. Okay. So that one's a no-go. All right. This one, it looks proportional, but it doesn't go through the origin. So that one's a no. This one, it's a straight line, goes through the origin. So that's a yes. All right. Yeah, some of these are giving me deja vu from last year. Like I remember you doing these also, and I remember you're pretty good at these. But you probably forget because it's summertime. Here we're starting with a fraction, so you just punch it in your calculator, divide it, 0.28. To convert that into a percent, you move the decimal over not once, but twice. Boop, boop. So it becomes 28%. 0.28 as a decimal is 28%. The same thing, calculator, and then move the decimal over twice to make a percent. Let's jump down to this one. So here we're starting with the decimal. Easy to get the percent. Move that decimal over twice. 32.5. I think normally we just use your calculator to do this. There is a way to do it by hand, but we're not going to take the time to remember that. You're just going to use your calculator. All right, those should be all set. Here you can see these are all combinations of decimals and percents and fractions. So to be able to compare these numbers, we should just convert them both into either percents or both into fractions or both into decimals. Probably decimals is the easiest. This is 1.2 as a decimal, right? Move the decimal backwards twice. And that is bigger than 0.975. Same, you can just use your calculator to turn that into a decimal. This one would be 0.08. And that's, I don't know what that is, probably like 0.65 or something. These ones, you probably remember this from last year. You just convert them all to decimals and then compare them and then put them in the right order. All right, I'm going to stop there. So let me know how it's going. Send me any questions, all right? Talk to you soon.